Let's determine the derivative of f of x equal to x minus the square root of 2 using the limit definition of the derivative. Recall that f prime of x is equal to the limit as h approaches 0 of f of x plus h minus f of x all over h. So in our case, what we have to find then is the limit as h approaches 0. Actually, let me move this down here so we have plenty of room. We need to find the limit as h approaches 0 of f of x plus h. So to do that, I use the function that we're given, and every place that I see x, I plug in x plus h, then minus 2, minus from our formula, and then we'll just plug in f of x, which is the square root of x minus 2, and divide that by h. Now if we do a direct substitution, what will happen is h will go to 0, and we'll be left with just the square root of x minus 2 minus the square root of x minus 2 over h, which is 0. Okay, so what we'll get would be 0 over 0, and that won't work. So we have to think of a new technique for us to do, and this is a technique that we've used in trigonometry, but we're going to use it slightly different here in calculus. So what we're going to do is a trick called rationalizing the numerator. So what we're going to have to do to remove the radicals, remember we're going to multiply by the conjugate. So this will be the square root of x plus h minus 2, and we'll still have the square root of x minus 2, but the conjugate is the plus. But we can't just do that on top, we have to do it on the bottom, so we have to multiply by the number 1. Okay, so we're going to multiply these two. Now, if we were going to multiply these out, we would get the square root of, so remember, a minus b times a plus b is going to be equal to a squared minus b squared. So in this case, what we'll have is the square root of x plus h minus 2, which plays the role of a. We have to square that. Then minus our b, which is the square root of x minus 2, and that has to be squared. And then we'll just copy the denominator. It's h times the entire quantity, square root of x plus h minus 2 plus the square root of x minus 2. Now we have a lot of work to do before we can take this limit, so let's just simplify this by using our algebraic properties. We know the square root of anything squared is just itself. So from here, we'll just get x plus h minus 2. We'll have a minus from the formula. And then here, when we square this, remember to open up your parentheses, we'll just get x minus 2 all over the square root, h times the square root of x plus h minus 2 plus the square root of x minus 2. So we have some canceling that can occur. This is going to be x plus h minus 2, now distributing your negative through, minus x plus 2. So these will cancel and the 2's will cancel, and we're left with just h. So right now we're at f prime of x is equal to the limit as h approaches 0 of just h over h, and don't forget your parentheses, times the square root of x plus h minus 2 plus the square root of x minus 2. Now if we do a direct substitution here, again, h will go to 0 in the numerator and h will go to 0 in the denominator, and that won't be helpful for us. So we still have to do some canceling. And then we're almost there. The limit as h approaches 0, we'll have a 1 left up top in the numerator. And the denominator is just the square root of x plus h minus 2 plus the square root of x minus 2. Finally, we're ready to take the limit. We'll let h go to 0. The only h we have in here in the problem is there, so that will go to 0. So what we're left with, we've taken the limit now, so we can drop the limit notation, is 1 over the square root of x minus 2 plus the square root of x minus 2, which is just equal to 1 over 2 times the square root of x minus 2. And that's it. That's our derivative. F prime of x is equal to this. Okay? And then we can evaluate it at any x that we would like. Let's say we let x equal 3. All we would have to do then is find f prime of 3, which is equal to 1 over the square root 2 times the square root of 3 minus 2, which is simply 1 over 2 times the square root of 1, but the square root of 1 is 1, so f prime of 3 is equal to 1/2.